Gautam sir, am I audible?
Sudipto, you are audible.
Okay, sir. We will wait for next 2 to 3 minutes.
5 minutes.
After that, we will start, sir. Okay.
5 minutes.
Because a few more participants will join with us. So we'll start.
Actually, today the time is changed now from 7
Yeah, but
to
we
6.
have notified. We have already notified to them.
Okay.
Okay. So we'll wait for next 2 to 3 minutes. After that, we will start the session.
No problem. No problem.
Thank you, sir.
Good evening, sir.
Good evening. Simon Ball. Hello.
As I join হয়ে গেছি জয়েনটা আসছিল না তাই জন্য ফোন করেছিলাম আপনাকে
না ঠিক আছে ঠিক আছে
ঠিক আছে
Good evening, Gautam sir.
Hello. Ajoy.
Ajay Yadav from Bharatiya. Very good evening, sir.
Yeah. How are you?
I am fine, sir. And you, sir?
Yeah. I'm fine.
Okay, very nice, sir.
So you understand a lot, no?
Yes, sir. I have attended so many classes.
Yeah.
Very knowledgeable classes. This is my luck, sir.
Very nice. Okay.
So good evening, everyone, and warm welcome in this faculty development program on multivariate data analysis and structural equation modeling using SPSS. This program organized by Bharatiya Vidya Institute of Management Science in association with SPSS and Indian Economic Association. So today is the 5th day and the last day of this 5-day FDP. And today we'll start with a practical session of multiple regression analysis. And after that, we'll go for structural equation modeling. And today we have a very esteemed faculty member with us, Dr. Gautam Bandhopadhyay, Professor, Department of Management Studies from National Institute of Technology, Durgapur. Thank you, sir, for accepting our invitation and taking your time from your busy schedule. And you have also agreed to take half an hour extra for our participants. So please, sir, please start your session. Thank you.
Okay. Thank you, Professor S. Ghosh. And thank you to all the organizers from Bharatiya Vidya Bhavan. So today, since it is the multivariate analysis class, so first for the first 5 minutes, I will discuss what is multivariate step by step. Then I will show you the multiple regression model using SPSS. Okay. And ultimately, then I switch to the structural equation modeling. Okay. So first of all, I'd like to share something. Just a minute. Share, yeah. Sharing is not coming. Disabled.
Now you can share, sir. Please check.
Thank you. Thank you. Yeah, yeah. So can I share the screen? Then anything will come, na?
Yes, sir.
Whole screen, no? Okay. It is coming.
I think it's loading, sir. Yes, sir. It's there, but not visible anything.
Not coming, na?
But your sharing is coming, but not showing anything.
Okay.
So just stop sharing and reshare.
Just a minute. Just a minute. Okay, again share. Then screen.
Yes, sir. Yes, sir. Now it's visible, sir.
Okay, we understand. Okay, just starting. Okay, this is coming.
Yes, sir.
Okay. Okay.
Yes, sir. Visible, sir.
So first I will say, because this FDP based on multivariate analysis, so I will take 5 minutes time to say what is about the multivariate. And finally, I will show you one simple case which solved my teacher, Professor Tathagata Bandhopadhyay. That case study initially is solved using SPSS. So first of all, what is multivariate? The sum, when you analyze some data gathered by some experimentation or observation, mainly we can collect some data from primary or as well as secondary. And different iterative process can be applied for adding or deleting the variables from the study. This is the main objective. You solve factor analysis. That is basically the dimension reduction. You solve, multivariate regression. That is also used for dimension reduction. You solve ANOVA, you solve logistic regression, discriminant analysis. So all are the multivariate analysis. And in some cases, we add some variable. In some cases, we discard some variable, which are not important. And to elicit information from these kinds of data sets using different statistical methods. And obviously, methodology used for this type of measurements on the data includes many variables called multivariate. Okay. Now, this is basically the 5 objectives of any multivariate analysis. The first objective is the data reduction or structural simplification. This is the first objective. And second objective is the sorting and grouping, okay, which we solve in the factor analysis class. Third objective is investigation of the dependence among variables. This is very, very important, investigation of the dependence among variables. Fourth is the prediction, because our objective is to fit a model. So naturally we go for the prediction. And finally, you go for hypothesis construction and testing. So these are the 5 objectives of multivariate analysis. So, and these are the applications of multivariate analysis. Already you solve multiple regression, factor analysis, cluster analysis not covered, logistic you solve, discriminant you solve, also solve the MANOVA. So these are the some application of multivariate analysis. Now, and this is a very interesting statement made by the FASC Marriott, that if your results disagree with any informed opinion, do not admit a logical interpretation and do not show up clearly in a graphical presentation. They are probably wrong. There is no magic about the numerical methods and many ways in which they can break down. They are a valuable aid to the interpretation of data, not the sources machines automatically transforming bodies of numbers into packets of scientific facts. So this is very, very important statement made by FASC Marriott. Okay. So with this, I go to SPSS for solving some regression problem. So this is it visible?
Yes, sir.
Yes, sir.
Yes, sir, it is visible, sir.
Okay. So now, first of all, Professor Tathagata Bandhopadhyay solved this problem nicely. That initially started with the simple regression and then ended with the class with the multiple regression. So already you know, in case of simple regression, there is one output and one input. But in case of multiple regression, there is a one output and more than one inputs. So problem is the why we go for multivariate analysis, because our explained part will be more, that part I'm showing with SPSS. So first of all, we go to the data view. So this is my data view. I have taken the 10 houses selling price and 10 houses sizes and age are given. So obviously we know the selling price is the dependent variable, or you can say output, and size and age are the independent variable. So these are called inputs. So what we'll do that, first we go to analyze. We go to analyze and go to regression and select linear. So we select selling price as the dependent variable and size as the independent variable. So first of all, I am showing the simple regression. So what is simple regression? Now we consider one dependent and one independent. And simply click OK. Okay. So we get this output. So here, first of all, this R is coming, that is called simple correlation, 0.813. And R square is 66.1%. So that means the 66.1% of the observed variation can be explained by the regression model. Okay. And this is the very, very important part, that is the adjusted R square. So there is some difference between R square and adjusted R square. So in the social science research, this adjusted R square is very important. Question is why? Because adjusted R square, basically, I will show you by writing, the adjusted R square, basically depending on the sample size, that is n, and also the number of independent variables. Okay. So that's why, but in case of the formula of R square, the sample size and number of independent variables directly not given. So if you check for your research, that here is a huge difference between R square and adjusted R square, that means you need some modification either with respect to your sample size, or maybe you have to increase the variable. So here some difference is not so high. It's a difference only 0.05 nearly. So this is basically the model summary. Okay. That is only 66% explained. So remaining 34% not explained. But the important thing is already you solve ANOVA. Okay. Important thing is regression. This is the ANOVA part. Because in case of regression, the total regression, they are divided into by simple equation. That is, there is the total sum of square, divided into one is the regression sum of square and residual sum of square. So there is called very interesting test statistics that is called F, and which is called the global test statistics. Question is why? Because if the F value is very large, then your regression model is good. F value is why? Because if F value is large means your error is less. Because F is ratio of basically to the regression model, mean sum of regression model by the residual model. So obviously, if F is large, that means your error is less and explained part of regression is high. And that's why this F statistics is very important in case of regression model. Okay. So naturally here the F value is 15.626, not bad. And the very, very important term is called degrees of freedom in case of regression model. Because suppose we started with, the total 10 observation and 10 observations and total sum of square, the degrees of freedom lose by 1, that is n minus 1. So 10 minus 1 is the 9 degrees of freedom. And how many, and your regression model, how many independent variable? Only 1. So that is the degrees of freedom is 1 for the regression model. And the residual is the degrees of freedom. There is 8 is the degrees of freedom for the residual. So this is a very, very important part, degrees of freedom. That part, when I start structural equation modeling, then degrees of freedom will take a very important role. Okay. Next part is that after getting this, you go for the coefficients. Coefficients means what is your model. So that part already discussed by Professor Bandhopadhyay. That is your A part and this is your B part. So naturally my model is Y equal to this 35,523.697 plus 59 point this into this. Okay. So that means per unit change of the size, your average selling price increased by 59 point this part. That part already explained. And already from the different knowledge of the significance of the p-value, that p-value will take a very, very important role in case of any statistical model. Because if in case of regression, if the p-value is less than 0.05, that means corresponding to that variable. So that variable will take a very important role for predicting the dependent variable. Okay. So this is the concept of the p-value is very important. So now I am coming to your the next part, which is the multiple regression. Say, go to analyze, and go to regression, and go to linear. So we select another variable, that is age. Because selling price, depending on size of the house as well as the age of the house. So maybe if the size of the house increase, the selling price also tends to increase, maybe. Similarly, selling price also depending the age of the house. If the age is increased, there is a chance of dropping of the selling price. There is a chance of dropping of the selling price. So we go for dependent variable 1, and there are more than 1 independent variable, and we calculate, click OK. So what we check that, if we click OK, so just a minute, we click OK. So we get it is visible to all of you. Hello.
Yes, sir. It is visible. It is visible.
Yeah.
Sir.
Okay. Okay. So if it is so when you select this, just you check here, R square is drastically changes. your R square is coming 0.916. So when you consider the simple regression, then R square is only 66%. 66%, and here it is coming nearly 92%. So the change of R square is 26% increased. So this is and automatically the difference between R square and adjusted R square is becoming less. Okay, only nearly 2%, more than 2%, nearly 2 to 3%. So that's why when you consider the multiple regression, your R square changes, and your F value is also high. In single regression, your F value is 15 point something, but when you consider multiple regression, F value drastically changes. It takes the higher value, that is the 38.268. So definitely the model is good. Model is good, and not only that, your unexplained part nearly 8%. So, and always you check the p-value, and all p-values are satisfied. All p-values are satisfied with this value. Okay. And naturally, the constant p-values is not satisfied because already Professor Bandhopadhyay, Tathagata Bandhopadhyay explained nicely that what is the significance of this constant. I'm not going in detail that part. But here, the variables are significant. Okay. So they are highly important for predicting, the selling price of the house. Okay. And definitely these are the coefficient, and on the basis putting this value, we can get some model. Okay. So if you have any question, you can ask me. Then I go for multicollinearity part. I will explain that because today I need for structural equation modeling. And I'm telling you, for structural equation modeling, I'll take the help of another software that is called AMOS. Okay. And for structural equation modeling, today I will show you the two things because time is a constant. One is the solve one regression model using structural equation modeling. Another is the factor analysis using structural modeling. Okay. So before that, you just tell me, first of all, if this part is clear or not. That is the multiple regression part.
Sir, the thing is, sir, am I audible, sir?
Yeah, you are audible.
Sir, my question is very simple. Suppose in this case, except the constant, others are very much significant. So when I write for reporting, then the model equation, in that case, since constant is not significant, so should I put the constant within equation or not?
That's why this is the real good question. Then you always consider the concept of the standardized coefficient. Okay.
Okay.
Because if we consider the standardized coefficient, then the constant directly is not coming. Clear?
Yes, sir.
So what is standardized coefficient? Just a minute, I'm showing that. Okay, just a minute. Very good question you asked. First of all, you tell me my board is visible.
Yes, sir.
Okay.
Yes, sir.
Last I'm telling you, say this is your regression equation. SY is it clear?
Yes,
Hello.
sir. Yes, sir.
So now we can easily write y minus y bar by SY is equal to R into x minus x bar by SX. Clear?
Okay.
Now this is equal to capital Y and this is equal to capital X. Okay? So that's why since R is the standardized form, so that's why it is called the standardized. Okay. So we are subtracting Y bar, not constant. we are subtracting y bar and dividing by standard deviation of y, we get the left hand side. And similarly, x minus x bar by sx. So what is the importance? When you write y minus y bar by sy, it is the unit free. No unit, dimensionless. Similarly, x minus x bar by sx, unit free, dimensionless. So this is the advantage of using the standardized coefficient. Okay. Because in maximum time, your constant is not the relevant. Maximum time. Because if you put what is constant? If we put x equal to 0, then we get the y equal to constant. Okay. And definitely you are y, what is the constant? That is the intercept of the dependent variable. But your constant, if sometimes it is relevant, sometimes it is not relevant. So when it is not relevant, obviously your H0 will not be accepted. Is it clear? Hello.
Okay, sir.
This is very important question you have asked me. So today, today I'll explain another concept, that the concept of VIF, because today I need this concept. Suppose, okay, better we solve using SPSS. Better using SPSS. You take this example and you go to analyze. Go to analyze and go to regression. Go to regression and go to linear. And you select statistics and select this collinearity diagnostics and you continue and then click OK. So just to check, this is your VIF values. Clear? That is the VIF values. So this is why VIF is important. So I am showing with some example why VIF is important. Just a minute. Say, suppose your y is the dependent variable and you have 3 independent variables. Try to understand 3 independent variables. So, number one is y having no relation with x1, x2, and x3. This is the first concept. Second thing, only with x1. Only with x2. Only with x3. Only with x1, x2. Only with x1, x3. And only with x2, x3. And finally, with x1, x2, x3. Is it clear?
Yes, sir.
So this is actual the case. So now, how many cases we consider? We consider no relation. This is one case. Only with x1. Only with x2. only with x3. So definitely there are total 8 cases. There are total 8 cases. And out of 8 cases, actually when you start regression analysis, there are basic 4 assumptions we have to follow. So what are the first assumptions? First assumption is the linearity. And we know the linearity we can check by the scatter diagram. That's what we know. Second assumption is the homogeneity. So what is homogeneity? Now your error must be homogeneous, and that follows the normal distribution with the mean 0 and the constant variance sigma square. That part already you know, E1, E2, E3 and so on. What is the third assumption? There will be no multicollinearity. This is the third assumption. Multicollinearity means the correlation between the independent variables. And what is the fourth assumption? Now there will be low autocorrelation. There will be low autocorrelation, because if the high autocorrelation occurs, then the regression analysis we have to solve. That is called the time series regression. So these are the 4 assumptions are very important. So now, and mainly when I'm showing that, so there are total 8 cases. So what is the problem of why it is called dimension reduction? So we have 3 variables, and then total parameter to be estimated, that is 2 cube, and that is equal to 8. Now problem is, suppose for some of our research, if we have 20 variables, so we have to compute to maximum 2 to the power 20, and that amount is 10 lakhs 48,576. So definitely we'll be mad after some time. So what is the problem? And that's why multicollinearity is very important. So if y having no relation with x1, x2, x3, then can be treated as a constant that is called beta naught. Beta naught. If only with x1, that is called beta 1. If only with x2, that coefficient is called beta 2. Only with x3, that is called beta 3. Only with x1, x2, that is called beta 4. And this is beta 5, beta 6, and beta 7. Now come to the next part. Say, I have P independent variables. Okay. So what is that? Suppose P variable, and there is no relation with the other variable. So that is, in mathematics, it is denoted by PC0. That is y having no relation with any one of the variable. So that is called PC0. P variable having relation with only a single variable, that is called PC1, and plus PC2. Similarly, PC3, and finally PCP. So that is, what is PC0? That is equal to 1, because single constant. What is PC1P? And in this way, that is basically binomial theorem. And that is nothing but 1 plus 1 whole to the power P, and that's why it is called coming 2 to the power P. But I'm telling you, in case of any multivariate analysis, we consider the relation between two variables. Question is why? Because I have 3 variables, x1, x2, x3. This x1, x3, x3 is the intersection of x1, x2, x1, x3 and x2, x3. Try to understand. Say x1, x2, this is the interaction relation between two variables, x1, x2. x1, x3, relation between two variables, and x2, x3 is the relation between two variables. So definitely, if we take the intersection of these, we get x1, x2, x3. So when there are three variables, only we find this correlation, x1, x2, x1, x3, x2, x3. If there are four variables, we find the correlation of 6, because three variable means 3C2. So three correlations. Four variable means 4C2. Combination is very important. That is equal to 6. Is it clear? Any question? Then I go to the next part. Hello. Not clear?
Sir, it's okay, sir. Okay. Fine, sir.
Okay. Okay. So now I am coming to this part. So therefore, just you remember one formula that maximum parameters to be estimated for any regression model, that is p square plus p plus 2 divided by 2, considering the multicollinearity. Multicollinearity means interaction between two variables. Okay. So now question is, why multicollinearity occurs? Why multicollinearity occurs? Suppose I am giving a simple example. Say p equal to 3. So that is equal to 3 square plus 3 plus 2 divided by 2. So naturally 9 plus 5, 14 by 2, we have to compute 7. Now we go up. Now we have to maximum. Now we go up. Very interesting. Why 7? Because this is no relation. Beta 1 means only with x1, only with x2, only with x3. Then 5, 6, 7, no need to compute x1, x2. Maximum. Is it clear? So definitely this x1, x2 means relation between x1, x2. That means correlation occurs between two independent variables. x1, x3, again correlation occurs between two independent variables. x2, x3, again correlation occurs between two independent variables. So obviously, if this type of correlation, if it occurs, so that is the multiple. So correlation, high correlation between the independent variable. And if high correlation occurs between the independent variable, then our assumption is regression failed. So when you go for structural equation modeling, then I will show you why regression failed. That part I will show you. Next part is very interesting. Say, why multicollinearity? Suppose I have four variables. Four independent variable, and x1 is a function of x2, x3, x4. What is the meaning? Meaning is that x1 depending on this 3. That means x1 is the dependent variable and these other 3 are the independent variable. So similarly, we can write x2 is a function of x1, x3, and x4. Similarly, we can write x3 is a function of x1, x2, x4. And finally, x4, that is equal to function of x1, x2, x3. So when there are four independent variables, then we have to consider four regression equations, four multiple regression equations. Is it clear? Hello.
Yes, sir. Yes, sir.
Yes, sir.
This is, and when we get this, the first equation, from the first equation, easily we can compute R1 square. That is how much x1 can be explained by the other three. Easily you can compute R2 square. Easily we can compute R3 square. And easily we can compute R4 square. So what is R1 square? Now, how much x1 can be explained by the other three? What is R2 square? Now, x2, how much x2 can be explained by the other three? So this is the meaning of R square. So if R1 square is very high, then definitely there is a correlation between x1 with the other variables. If R2 square is very high, there is obviously there is a relation between with the other variable. And I'm telling you, if for some problem, if you check that this R1 square is very high, R2 square is very high, R3 square is very high, R4 square is very high, automatically regression failed. Then we welcome the other method, factor analysis, PCA. Okay, because all are having the high multicollinearity. So, but it is not possible to solve all types of regression. Then summarization all, we find what is the unexplained part. Unexplained part basically 1 minus R1 square, 1 minus R2 square, and so on. So naturally we can write 1 minus Ri square is the unexplained part. I is equal to, if there are 4 variables, I running from 1 to 4. Ri square. So this is called the, unexplained part. And using this unexplained part, we derive one formula that is called VIF, variance inflation factor. It is nothing but, 1 minus Ri square. And definitely, already there is a rule if VIF is in the social science, mainly we are taking VIF 2 to 5, is a high VIF. There is a high multicollinearity. Similarly, if VIF is 5 to 10, that is also high multicollinearity. And if VIF more than 10, so obviously huge multicollinearity. So if we check for some problem, that your VIF is very, very high, more than 10, more than 8, 9, 14, 15, so obviously regression failed. Okay. So that part, I will show you some example. That means when we consider from regression to factor analysis. Okay. So this is basically PIF. So now we started with some example. Then you can easily understand that. Say,
Excuse me, sir.
yeah, tell me.
Sir, when we calculate the regression, what is the good value of VIF?
Okay, PIF actually I'm telling you R square is equal to 0.5. Then VIF is coming 2. You put the value 2. Okay. That means for the some social science, we take the R square if 0.5 to 0.8. That means VIF lies between 2 to 5. Okay.
Okay, sir.
So that is our, okay, some literatures are showing that is a very good. R square is 0.1 means 50% explained. Okay. But if R square equal to 0.8, then VIF is coming 5. So that means if R square lies from 0.8 to 0.9, then VIF lies between 5 to 8. Clear? 5 to 8.
Yes, sir.
And,
Yes, sir. Yes,
and
sir.
if R square is equal to 0.9, then VIF equal to 10. 10. And obviously, your R square, when R square lies between 0.9 to 1, then VIF lies between 10 to the mole value, infinity. Okay, that is a high value. So this is the case of VIF. And actually, when you solve any kind of, I'm telling you, very interesting part. When you start your work, maybe you get some dependent variable from your domain, and you get some independent variable. And that means we can say this is basically the supervised model. Supervised means for your model, there are some output and there are some inputs. So for this seminar, you solve the first day, that is called the unsupervised. That is the factor analysis. In the second day, you solve regression, that is the supervised. In the third day, you solve ANOVA, that is also supervised. In the fourth day, you solve the logistic discriminant, that is also supervised. And today, you are solving the conformity or validation of any supervised model or the unsupervised. So question is, that is the very interesting, when you start your research, maybe for your research problem, you have some dependent variable and you have some independent variable. You have. But you started with regression, but your regression failed due to multivariate. Then what you will do? You go for PCA. You take the help of factor, exploratory factor analysis, CFA, you solve this. And after doing this, again you solve some regression model, because then you get some R square value. So I'm giving a very interesting example. This is basically a cyclic process. So why it is cyclic? Say this is your, just follow my flow chart. This is your dependent variable. And there are so many independent variables. Follow my flow chart. That means basically this is the regression. More than one dependent. Basically, you are solving LR, DA, and so on. Discriminant analysis depending on some condition. That part you solve. Okay. And when due to some multicollinearity occur, due to some autocorrelation, your regression disturbed. Then what will do? So we have to search for the other model. So we go for the PCA, basically PCA or FA or EFA, and finally you go for structural equation, that is called CFA. So you solve this, and then after solving,
Hello, sir. You are not audible, sir.
I think that sound is not there.
Dr. Sudipu, please check with sir.
Yes, sir. I am just trying to reach him.
Okay.
Hello. Actually, sir, laptop is going switched off. So sir will join after 5 to 10 minutes. Just wait for 5 to 10 minutes. Actually, I talked to Jivi sir, and sir told me that his laptop is going switched off. So it will take 5 to 10 minutes. Okay.
Okay, sir. Okay.
That's why my connection is not connected with the GB sir. I'm just
Yeah,
trying to reach him. Okay.
yeah. Just
Okay.
wait.
Thank you, Shan. Thank you.
Okay.
We'll wait for him for next 5 to 6 minutes. So you can take a break to all the participants. You can take a break for 5 to 6 minutes. So after that, we will start again. Okay. Thank you. Gautam sir, is it okay from your end?
Sorry. Okay. My voice is audible?
Absolutely, sir. Absolutely. You can start,
Sorry.
sir.
Sorry. Please,
No
sorry.
issue, sir. No issue. Please continue.
So, 1 minute just sharing. This is coming?
Yes, sir. It is visible, sir.
Okay. So now just to check what's the problem. So this regression failed. So obviously it comes to the supervised model. Then we apply PCA, FA, EFA, CFA, or we can go for clustering, anything. So many supervised, unsupervised model. And after applying this unsupervised model, basically unsupervised model means grouping. And that is one property of multivariate analysis, grouping the variables. And after grouping, so then again we can run regression. Now, what problem we'll face? Because we know the regression divided into two parts. One is called exploratory model. Exploratory model. And one is called predictive model. That is basically regression. So what is exploratory model? That is without multicollinearity. Without multicollinearity. What is predictive model? Some multicollinearity we can consider. Because in case of real life problem, it's really impossible to get the exploratory model. There are some interaction. If you solve some problem with the primary data, maybe some secondary data, so you get some model where there are some interaction with some variable. So that's why I'm written some multicollinearity we can occur, and that is treated as a predictive model. So when huge multicollinearity occurs among the predictive variable, so then regression failed. So then we have to go for some unsupervised model that is like the PCA. And that's why PCA is a very famous model. Okay. Now, this is basic thing. Now, concept is Basically, we apply SEM for basically for the primary data. But today, in one session, it is not possible to show because then otherwise, because if we apply the primary data, then we have to check before SEM the reliability as well as the validity. So I have no time to that. So I will show you some concept of SEM using some secondary data construct. Okay. But mainly, if we solve some primary data research, so obviously you have to solve some structural equation modeling. And before coming that, I'm telling a story that what is about the construct. What is about construct? Well, suppose we know that in our class 9-10 level, this is a very famous example given in the Johnson Wichan in some other language, but I am converting into the English language. So there are 7 subjects we are, teaching or taught in class about 9-10 level. That is called physics, chemistry, mathematics, Bengali English, and history, geography. These are 7 subjects mainly. And we know that physics, chemistry, mathematics, it has a name that is called basic science. Basic science. Bengali English has a name that is called language. And history, geography has a name that is called social science. And these are called underlying construct. That means we know the physics, chemistry, mathematics are called basic science. We know that is Bengali English are called language. And we know that history, geography are called social science. And now on the basis of these, we collect the data. We collect the data. Say we collect some 100 students' data. And these are the 7 subject marks. 7 subject marks. And these are the 100 student data. So this is my database. So my database, say 100 by 7 matrix. And these all values in scale variable. Scale. All values in scale. And these are all values out of 100. What is our objective? To establish. Empirically, we like to show that our construct is correct. Our construct is correct or not. Because we know that PCM will form the basic science, Bengali English will form the language, and history, geography will form the social science. Then what will do that? We construct initially a covariance matrix. Covariance matrix. And covariance matrix. Then we convert covariance matrix to correlation matrix. Correlation matrix. So what is the difference between covariance matrix and correlation matrix? Because in the covariance matrix, this is not the standardized. The covariance matrix is not the dimensionless. The covariance matrix is not the unit free. This is the real problem of covariance matrix. But when you solve any kind of structural equation modeling, so we have to take the help of covariance matrix. And what is correlation matrix? Now, correlation matrix is the standardized. Its value is less. Value is less and it is the unit free. Because we know the correlation lies between -1 to +1. That we know. But this covariance matrix lies between -infinity to +infinity. This is the one problem. Next is, in case of covariance matrix, we take the diagonal as the variances and off diagonals are the covariances. And in case of correlation matrix, diagonals are the one and off diagonals are the correlation between two variables. But in both the cases, in case of covariance as well as correlation, they are the symmetric matrix. Symmetric matrix. Okay, that is the correlation between XY is same as correlation between Y and X. Similarly for covariance. So I'm telling you what is the objective of this. So with this 7 variable, we construct a 7 by 7 correlation matrix. And already you know, on the basis of this, we find the eigenvalue. That part I will not discuss. And since we get 3 eigenvalues, we get the 7 eigenvalues because it is a 7 by 7 matrix. And out of the 7, the 3 eigenvalues more than one, and that we can say it forms the 3 groups. It forms the 3 groups, 3 factors. Now the problem starts that when you form the 3 groups, then it is called physics, chemistry, mathematics in one group called Bengali English, and one group is called history geography. So that means why PCM in the same group? Because they are highly correlated with each other. So this is the within group correlation is very high. That's why it is called intra correlation. Intra means within group correlations are very high. Similarly for Bengali English within group, history geography within group. But when they are in the separate group, that is called the between group. So we have to establish that between group correlation is very less. Otherwise, they will not form the group. Okay. So this is the main objective. Now, question in the real life, a student good in physics, good in Bengali also. A student good in maths, good in English also. So obviously, there is the interaction between the members of the two groups. Okay. And that's why there are 2 types of operations we apply. So when all groups are different, that is basically called orthogonal transformation. And you know, we apply the Varimax transformation. But when there is the interaction between the groups, that is, we apply the oblique transformation. And that is the transformation is the Pomax oblique mean. These are called oblique transformation. Okay. That part I'm not discussing mathematical part. This is the concept. Okay, why we go for different types of transformation. So, I know what is my task? My task is today's class. Your regression complete. I have to validate is regression is correct. Say your factor analysis is complete. I have to validate your factor analysis is correct. And now when you face the problem, I'm telling you, when you face the problem in factor analysis, not only factor analysis, when you solve some problem with PCA and EFA, and ultimately you go for CFA. So I'm telling one very interesting thing. Suppose you are collecting 50 data set. Don't go for directly FA for this 50 data set. So then try to find some underlying constructs from the literatures. Question is why? Because if you solve for the 50 data set, your reliability always high because your sample size is very big. Your number of variables are very high. So this is the real problem. So first of all, you have to try to find the underlying construct. And if you get the underlying construct, it is already defined in the literature. Suppose underlying construct is already defined. You know the construct 1 given 7 variable. Construct 2 given 9 variable. Construct 3 given 10 variable. You separately solve the factor analysis. And after solving this, directly you go for CFA. So it's my request to all of you. There is a very interesting case which is available in Google. That is the personality, 5-dimensional personality problem. 5-dimensional personality problem. And there are total 55 dimension, openness, extra, neutralism. I'm not going that. So there are that you study. for factor analysis, which is very helpful. And these 50 questions divided into 5 dimensions, and they solved, factor analysis for individual dimension. Ultimately, they solved the CFA with the 5 dimensions. Okay, that part today maybe not possible to show that. I will show you a very small case due to the time. Okay. So this is the one case. Now coming to my structural equation part. And another thing is very important when you go for structural equation. So that is called degrees of freedom. I hope this term is already know what is degrees of freedom, because you studied in ANOVA, you studied in MANOVA, you studied in logistic regression, you studied in, regression, everywhere degrees of freedom is important. So I'm giving question is why it is important. Because when you go for any model, so model divided into 3 parts, 3 parts. What are the 3 parts? Now we have some independent model. We have some hypothetical model. And we have some saturated. What is that? Say, when you go for regression, so we try to get the independent model. Question is why? Because we are not considering multivariate. That is a regression model. We are not considering multivariate. So, but in case of real life, there are some interaction between independent variables. Okay. So that means their independent model tends to the hypothetical. And if the hypothetical model tends to saturated model, that means model is finished. What is the meaning of this? And why independent model tends to hypothetical or hypothetical model tends to saturated? Because your degrees of freedom is decreasing. Then when your degrees of freedom will decrease, and if it tends to 0, then you can sure about it that your model is saturated. Either for regression, either for logistic, or anyone. Okay. So that part you can solve by the SEM, structural regression model. Okay. Now, question is, what is degrees of freedom? This is very important. Because in the definition is the number of independent parameters. But what is that? If I ask you, say this is a box, then easily you can understand. This is a box. And in box, there are total 5 balls. 5 balls. 5 balls. And if I ask you, what is the chance of drawing first ball? So definitely these 5 balls are the different colors. Different colors. Someone is black, someone is white, someone is green, someone is yellow, someone is brown. Those are the different 5 colors. Now, what is the coming of the first ball? So obviously 5 ways. Any ball may come. What is the coming of, and when first ball is coming, so 4 balls are left. What is the coming of the second ball? So that will come in the 4 ways. What is the coming in the third ball? There is the 3 ways. Coming in the fourth ball, 2 ways. And when the last ball is remaining, so there will be no choice because last ball is remaining. So that is what is the degrees of freedom? There are degrees of freedom is n-1, and that is equal to 5 minus 1, 4. Next example is, because why 4? Because 4 balls, they are independent. Independently we can consider, but the last ball depending on the force. So that is the degrees of freedom is 4. Okay, similarly, there are so many examples like x plus y plus, this is a famous example, x plus y plus z equal to 6. And naturally z equal to, 6 minus x minus y. Here z depending on x or y. So definitely the degrees of freedom is 3 minus 1 equal to 2, because we consider, the different values of xy for which z is dependent. Xy can take the several different values, but z is dependent. They will change on the basis of x and y. So what is the degrees of freedom 2? Next is that. So today I'll show you some concept why the correlation is important, that say what problem we will face. Say you collect some data. And in this data, there are, say, 7 variables, okay, 7 variables, and say observations, say 50. So it is a 50 by 7 matrix. Okay. And out of these 7 data, 50 into 7, that is, there are total 350 cell value. 350 cell value. Out of 350 cell value, maybe 5 values are missing. And if the 5 values are missing, that means only 350 values, 345 values are available. And 5 values are missing. So naturally, you are puzzled that how we manage these 5 variables. And if you can manage, you have to search. So there is again, you have to take the help of missing analysis, which is another module of SPSS. And with the help of missing analysis, there is another task. But if we want to solve without the missing analysis, then what we'll do? And because of this, when you go for structural equation modeling, and if you supply the data in software like AMOS with the missing values, the software will not run. Simply, software will not run. So AMOS will fail. Question is why? Because AMOS will not work with the missing values. So how we matrix is given and you divide and form correlation matrix, easily you can derive the covariance matrix. So just only we have to supply the mean of the variable. For model testing and results, and in this way, this is basic approach of performing a SEM. Now, very interesting. we need to know only the four things. What are the four things? So we need to know the four geometric figures, that we have to know the knowledge of what is circle, what is rectangle, and this is the single-headed arrow. Okay. So what is the, and this is the double-headed arrow. So what is the meaning of circular, circle or ellipse that represent unobserved latent factors or variables? Unobserved latent factors or variables. This is the rectangle or square, represents the observed variable. And this is the single-headed arrow, represents the impact of one variable over another. And this is the double-headed arrow, that is the represent covariance or correlation between pairs of. First of all, tell me this is clear or no? Hello? Hello? I hope it is clear.
Yes, sir.
Yes,
Yes.
sir. Yes, sir.
Now, I hope. So now, so naturally, when you draw the diagram, now coming to the, this is very, very interesting part, that, okay. So I'm not going in detailing mathematics. So already I told you that few words about structural equation. One thing is very important, just you try to remember. One is called identification, that part I will discuss. Here, some multivariate, we need some probability distribution, that is called central chi-square and non-central chi-square. And already I told you there are three models: independent model, hypothetical model, our model, and saturation. Few words. And this is very important. Already I told you we need the covariance matrix, degrees of freedom. Okay. And this is required for making hypothesis. And mainly we need the calculation of degrees of freedom, and mainly hypothesis construction and test. This is required actually. That part I will show you one by one when you draw the graph. So this is the steps to be followed in SEM. First of all, SEM is the problem specific. Already I told you, we have the theories, construction is perfect. Okay. If your regression is not valid, your SEM will not work. Your factor analysis is not good, your SEM will not work. Okay. So SEM is the problem specific. You have to identify the problem. And there are different 5 methods. This is the statistical method. Okay. Programming part I'm not discussing. And you have to check before running SEM if there are the outlier for your data, so SEM will not work. And if your data set is not normal, your SEM will not. So definitely if there is outlier, huge outlier, so there is a less chance of normality. So that's why this is very important for before starting SEM. Now, these are the methods for calculating. Okay, that part I will show you. And this is very important. Suppose you are solving some problem using SEM, and you have to represent in some research paper. If the research These are called absolute fit. Similarly, these are called relative fit measures. Okay. And these are called parsimony fit measures. These are called some measures based on non-central chi-square. These are called non-central measures. Everything is available in AMOS. But you have to say in the research paper you write that these measures based on non-central chi-square. And this is some information theoretic fit measures, AIC, BCC. And finally, the last fit index, checking your sample size. Okay. So these are the different fit measures of SEM. And now I'm showing basically what is CFA. Already you solved PCA. Basically, PCA is nothing but the component analysis. Now, what is component analysis? Now, direction towards factors without error. This is very interesting. Direction factors without error. What is the meaning? Now, factors, suppose you have 20 variables, and all factors are the linear combinations of the all of the variables. So factors will be in the left-hand side, and all the linear combination with the variable will be in the right-hand side without error. That's why I've written direction towards factors without error. So that is basically PCA. And for PCA, you can find correlation or covariance matrix. You find the eigenvalue that you know. Now coming to the part EFA. So when you start EFA, that will come after PCA. So what is EFA? Now direction towards manifest variable, that is your observed variable, with error. That means from PCA, you know that is how many factors you have. Say you study, say 20 variables. And these 20 variables, say, decomposed into 3 factors. That means you know your 20 variables decomposed into 3 factors means there are 3 factors needed, 3 groups. So then in the left-hand side, then the right-hand side you write, direction towards manifest variables with error. That means variables will be in the left-hand side, factors will be in the right-hand side with must be error. This is very, very important. Then we can run the regression analysis. So in case of EFA, variable in the left-hand side and factors in the right-hand side and plus error. That is variables depending on the factors. So that is basically the EFA. And what is CFA? Now, same as EFA and covariance is among the factors. So we include only the covariance among the factors when you draw. That is basically CFA. So that is basically difference between PCA, EFA, and CFA. So today mainly I solve only CFA because I have no time to discuss about EFA because EFA is very, very important. Okay. So and now I will calculate the calculation of number of parameters. That part I will show you. Okay. So better when I'm doing that thing. Okay. First of all, you have to know that what is the meaning of latent variable. Latent variable, very interesting because it is called the unobserved variable. And say intelligence is the internal structure of mind, which is not observable. When suppose an intelligent test has 30 items of 5 scale. 30 items have 5 scale means say like a scale 1, 2, 3, 4, 5. So each item having 5 scale means 30 item 5 scale. So total score, maximum total score will be 150 and minimum score will be 30. So naturally your IQ score lies between 30 to 150. And that measure is called ordinal measure. So using different standardized conversion like ZT and so on, someone can get a scale of IQ is 120. So is the indication of just a relative position. The score of IQ 120 is not the latent variable, but it is the intelligence that is causing the score on this 30. I hope this is very interesting. When you get a good score, so that is the cause of, that means your intelligence. So cause That is basically, the latent variable. Okay. So that's why it's very important. Now, what are the steps in CFA? First of all, we need theory, then we need data, and we construct the model. Why model? I can go for any supervised model, or I can go for any unsupervised. So specify model. I have to know what type of model we can use. Test for identification. This is spelling is wrong. Identification. Estimate model parameter. Okay. Model parameter means the coefficients of the variables. And statistical test and fit indices. All there are already I have shown how many fit indices. And compare different models and interpret and conclude, and then graphical model. Okay. Then graphical model means draw the figure. Okay. So when you write, the research paper, so just you follow this concept. Okay. This is the 9 steps. And so obviously, so when you go for any structural equation modeling like CFA, or you have to some assumptions. So what is the assumptions? I'm giving a simple example. Say, considering the example of 6 variables with 2 factors. That means 6 variables decomposed into 2 factors. Where each factor contains 3 variables, no variable is common. So we are relieved. We are relieved. But today I will show you one example when there is a common variable which interacting both the factors. That is the real problem. And when you solve the real life problem, so you will face this. That one problem one variable interacting both the factors. That means that factor having the influence on both the factors. Okay. So, but here I am giving the example that is the 6 variable with the 2 factors and no common variable. Okay. First of all, which is known? Since the variables are known, we know the capital S, that is the sample variance covariance matrix. We know this easily. We can compute the sample variance covariance matrix. Why variance covariance matrix? Because diagonals are the variances and off diagonals are the covariances. And why it is sample? Because based on the which is known value, that is a sample. Which information we collect either by the secondary or by the primary data source. So that's why it is called the sample variance covariance matrix. Now, what is sigma, capital sigma? That is the population variance covariance matrix, which you don't know. So that's why it is called unrestricted. But when you estimate some parameter that is called sigma theta, so then it is called restricted. So there are 3 notation are very important. One is capital S, one is sigma, capital sigma, and what is capital sigma within based function of theta. These are 3 notation. So what is capital S? Because this is the sample variance. What is capital sigma? This is the population variance covariance matrix, and which is unrestricted. And what is sigma theta? Now that is the model implied variance that because it is restricted on the depending on the parameter. Okay. So these are very, very important notation, and these are the assumptions. Certain assumptions are required to estimate the structural coefficients. One assumption is the mean of the observed and latent variable is 0. Mean of the observed and latent variable is 0. And the relation between observed and the latent variable are linear. Already I told you. And there are assumptions about the measurement error. The errors are mean 0. That part you already know in case of regression. The errors are constant variance. Already know. The errors are independent. That is also in case of regression. And the errors of uncorrelated with the latent variable. So these are the assumptions. So when you write this paper, so you have to try to establish this assumption. Okay. So okay, now I am going to the some example identification. I will give the concept. I'm not reading. Identification is very important. Then estimation part, basically theoretical part. And model evaluation is the theoretical part. and there are different types of. This is very important. When you write your research paper, so you give this hypothesis. Why you give this hypothesis? Because this is your, because this is, since it is the multivariate analysis, and in the multivariate analysis there are the first object 5 objectives. So one objective is the your simplification, dimension reduction, and what is the second objective? Grouping and sorting. Third objective is dependence among the variables. Fourth objective is the prediction. And the last objective is very important, that is the construction of hypothesis and testing. So this is my construction of hypothesis. So this is the construction of hypothesis in case of SEM. So I'm telling you, when you apply regression, you have to write the hypothesis. When you study, ANOVA, you have to write the hypothesis. When you study logistic, discriminant, you have to write the hypothesis. So this is the hypothesis construction is very important. So this is the construction of hypothesis, that is the sigma equal to sigma theta. Why? This sigma is the unrestricted population variance matrix, and sigma theta is the restricted population covariance matrix based on theta. So this is called hypothesis. And until your H0 is satisfied, your the same is not satisfied. So that is, and this is my test statistics. Here we apply central chi-square. I'm not going in detail about that. So this is the evolution of null hypothesis. And we know we check this null hypothesis by the p-value. So if the p-value is more than 0.05, then H0 is accepted. So until that is our main requirement for the structural equation modeling, your H0 is accepted or not. Okay. Next case is that these are the different features. The theoretical part is given. I'm not going that. So I hope if you have any question, because then I will go for application part with one. First we'll show the factor analysis, and then I'll go for regression. If you have any question, you can tell. Okay. So I'm coming to the next part, which is very, very important. Suppose just a minute, huh? Okay. Is it visible?
Yes, sir. Yes, sir.
Yes, sir, it is visible.
Okay. So very interesting. So first we start with the regression, because it is very interesting. Because you solve as regression started with. So in case of regression, there are all are observed variable. So one observed is called dependent and other observed are called independent because all are known. So here, this is the, so what is the example? First of all, we have to understand the example. So I'm taking a data set of, this is the data set. So just to check, first we go to the variable view. So there are 7 variables, and this is the case of some organization. So organization, there are 474 employees, and they are getting salary. And their salary is called, so today which I am getting the salary, that is called current salary. And current salary, depending on so many parameters. So when you joined, then your salary is beginning salary. And when you join, you have some educational qualification. You have some job category. You have some previous experience. You have some minority classification. There are so many things. So here, for this problem, the current salary is the dependent variable, and all other 6 variables are the independent. So what we have done, this is basically very style of writing code in SPSS. Style of this. So here is no data. What I have written, so we know the SPSS, there are 5 parts. First part is the variable view. Second part is the data view. Third part is the output view. Fourth part is the draft view. And last one is the syntax. So that is basically, if we go to, this is my variable view. Now what is variable view? Now these first 2 lines, that is under name column, are fixed. You have to write. This is basically Python code. That is row type underscore and var name underscore. This is fixed for any, either regression, logistic, you have to write anything. And not only that, you can apply for, for any kind of optimization, like you are solving DA. Okay, you can apply this. This is fixed. And then under variable view, how many variables involved, you have to type. So here, the 7 variables involved, you have to write. And then you have to give only the data type. Here row type is the string, variable name is the string, and definitely all variables are numeric. Okay. So again, repeat, the first 2 lines are fixed. And this naturally, after finishing the class, I will send the PPT to Professor Sudipta Kumar. So you will circulate, no problem. Just to understand. So these are the variables. And definitely these are the width and decimals. So first we create variable view, and then we go to the data view. So what is data view? Now under row type, we write n is the sample size. And how many variables? 7. That's why I type 7 core. Core means correlation. And then I write standard deviation, and then we write mean. And we put n, and how many variables? 7 variables. 7 variables. And for each variable, there are 474 observations. And that is denoted by n. And this is my correlation matrix. And since we know the correlation matrix is symmetric, so no need to write the upper diagonal part, because these are all same, because it is a symmetric matrix. Okay. So I have written only the correlation values. Okay. And this is the standard deviation for each variable and mean for each variable. The question is why we need standard deviation and mean? Because when you supply in AMOS this file, AMOS automatically calculate the sample variance covariance matrix. Because if we know correlation, And if we know mean and standard deviation, only easily we can compute the covariance matrix. So that's why we have to supply the standard deviation for each variable. So as well as for the mean for each variable. So this is the file, and definitely I have to give the name of the file. Now, doing this, we go to the diagram. And when we draw this diagram, just to check, initially there is no point. Just a minute. These are no. This is the initial diagram. So what is the initial diagram? Because current salary is the observed variable, which you know. And these are all, I have taken only 5 independent variables. The question is why? As a minority classification is not important for predicting the current salary. So I have discarded it. Okay. So I have taken the other 5 variables. So just to check, for salary is the dependent. Salary is the dependent. Again, repeat, salary is the dependent. And these are independent. So this dependent variable, in terms of structural equation modeling, is called observed endogenous variable. Again, repeat, dependent variable, in terms of the structural equation modeling, is called endogenous variable. Endogenous, observed, endogenous. Observed means we know the variable. Why it is endogenous? It is dependent. And when the independent variables, these are the 5 independent variables, so that is also known. That is also known values. And that's why these are called observed exogenous. So there are 2 things. One is the endogenous, one is the exogenous. For endogenous, that is observed. Exogenous, that is also observed. But here, we draw one circle. We draw one circle. So definitely we have given, if it is circle or ellipse, that is called unobserved variable. Unobserved variable. So I'm telling you, when you solve any regression model, so you have taken the dependent variable in the left-hand side and all independent variable in the right-hand side plus error. Now, what is error? Error of dependent variable. So that's why the direction of error in the dependent variable. So question is, when suppose I am the really new, I don't know anything that how I draw the figure. So what I'll do that, I'll go for, I'm showing you one thing, I'll go for a new this. Do you want to, if your answer is no, you're changeable. If you, okay, yes, I want to, yes. Now it's my new Amos. Now I want to solve this regression model by Amos structural regression modeling. That is a good model or not. Okay. And after solving R square, you are getting very nice. Very nice. Maybe you get some VIF, everything you already completed in your regression model. Now you have to check your regression model is confirmed or not, good or not. Your all types of measures are satisfied or not. And then you can write these all measures are satisfied. So definitely confirm this is a good model. So this is your work. So how I draw the model? So I know this is my observed variable. Simply you come to this and you draw the observed. Simple. Draw the observed. Draw the observed. Because I'm the, suppose we are the beginners. We are the beginners. So there are so many plugin software, I will not show it in the first class. So then easily, automatically you can draw when you will be the master. And this is the dependent variable. Okay. Okay. So now I have to give the name of the variable. Name of the variable. So, okay, another thing. So I have to give the arrow. So what is the arrow? Arrow is this variable, this direction towards dependent variable, direction towards dependent variable, direction towards dependent variable. Is it clear? Hello?
Yes, sir.
Yes, sir.
And
Yes, sir.
and we have to give arrow this circle, because circle is called error part. Error part. And this direction also, this direction also, this dependent variable. Dependent variable. Now, next question is, what is the name of this variable? Name of this variable. So obviously we have to give the name of the variable, say V1, V2, V3. How we can give? Suppose I'm the beginner, I don't know anything. So then what we'll do that? We give the right click. So there will be coming object property. And if we write V1, it will come automatically. That is the variable one. You can write your any name, okay, employee code, anything. Similarly, you can give V2, okay. In this way, you can put the variable. I hope it is clear. In this way, you can put the V1, V2, or employee, salary, a previous experience. According to your database name, we can put the name. Okay. So that part we can easily solve. Now, and if you, okay, that part I will show you finally. So question is, suppose after drawing, the very interesting part is left. That we have to give the name of this. This is called error. This is called error, E. And okay, this is called error. Now I'm coming to next part. This is very, very important. The next part. Say y equal to, just a minute. Y equal to say B1x1 plus B2x2 and dot B5x5 plus E. This is my model, regression model. Okay. And here we consider only standardized model because there is no constant. Just you check y is the dependent variable. And this is the error. And what is the coefficient of error? 1. What is the coefficient of error? 1. But what is the coefficient of x1, b1, which is not known? What is the coefficient of x2, b2, which is not known? Similarly, coefficient, this is not known. Now you come to the diagram. Now you come to the diagram. Now you come to the diagram. Okay. Now you come to the diagram. 1 minute, huh? 1 minute. Now we come to the diagram. Just a minute. Okay. Now we come to the diagram. Very interesting. Say this is 1. So how we are giving one? Just simply you give the right click and object property. This is nothing but you go to the parameters. It is nothing but the regression weight because coefficient is 1. Is it clear? You have to give 1 because the coefficient of error is 1. Okay.
Yes, sir.
But here, this is the regression weight. This line, we don't know. This is the regression weight, we don't know. This is the regression, we don't know. This is the regression weight, we don't know. This is the regression, we don't know. Now I want to solve that my regression is correct or not. I don't know anything. Just I have done this and I have given the data. So how? First question is we draw the diagram. Draw the diagram first. And these are the name of the independent variables. And this is the name of the dependent. So what I will do that? First we collecting. This is the symbol. Select the data file. Just to check. Just watch this arrow movement of my mouse. This is the select data file. So this already data file is selected. I have selected this data file. Click OK. This is, that means already I have saved in SPSS that file. Okay. And we go for, so already I told you there are different methods. So these are the different methods. First of all, since you are the, if you solve initially, don't go for any kind of estimate, just you go for output. And in output, only you select, this is the modification index, only. Only you select the modification index that is already selected. And here it is given 4, no problem. I will explain why it is 4. So first we select modification index, nothing else. So, okay. So what we have done, you first step is you select the data file, that is including correlation matrix. Now use the method, only select the modification index. Now you run the process. You run the calculate the estimates. What we are calculating? We are calculating the chi-square value using the test statistics value, and we are checking your hypothesis correct or not. Very interesting. Hypothesis correct or not. That means we are checking our p-value is more than 0.05 or no. That is our checking. Now what I'll do that, we calculate this. Very interesting. What is given? Just to check that salary began with a relation with the job time. Salary began with relation with job cut. So proceed with the analysis. Yes. Question is why? Because there are how many variables? Independent 5. So out of 5 independent variables, how many correlation we can construct? 5C2. Because 5 variables, so there are 10 correlation can be constructed. Okay. So now I need the output. My result is correct or not. So that is my output. So that is called view text. When you view text, so just a minute. Yeah, this is my output. This is very interesting. First of all, you have to check how my output is correct or not. Suppose I don't know anything about degrees of freedom. I don't know anything about number of sample moment. No need to know. Just you select only estimates. Just you select estimates. Then you can understand.
Excuse me, sir.
Uh,
Sir, please show me 2-3 step beginning.
hello.
So just show me the beginning process of this figure.
Beginning process for before coming this text.
Yes, before this commented, I want to see some mistakes. I just have to.
So, but one thing I do, I'm one thing do. First we solve this, then I can repeat.
Okay, sir. Sure, fine.
I'll repeat. I know. I'll repeat. Because again, I will repeat in case of factor analysis also. Just wait. So just you think why I have taken estimates. You calculate your salary is the dependent variable, and salary begin is the independent variable. So this is the regression coefficient of this. Similarly, this is the regression coefficient of this. 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 Is it clear? Hello.
Yes, sir. Clear, sir.
And these are the variances. Variances is 1, 2, because why we are calculating variances? We are calculating variances for independent variable, and also we are calculating variance for latent variable, that is error. So we are calculating 5 regression weight and we are calculating 6 variances. So in total, we are calculating 5 plus 6, that is 11. Is it okay or no? Hello.
Yes, sir. Yes, sir. Clear, sir.
First of all, you tell me it is clear or not. Then I'll go to the next step. Because it is the ultimate. If you calculate 5 regression weights and you calculate 6 variances. So what is the meaning? Meaning is that initially we have one dependent variable and 5 independent variable. So that is 1 plus 5 equal to 6. And this is my covariance matrix. This is my covariance matrix. 6 by 6. Clear? Because we have total 6 variable, 5 dependent, 5 independent, 1 dependent. And when we have 6 variable, we can construct a 6 by 6 variance covariance matrix. Variance in the diagonal, covariance in the off diagonal. So total variance we compute 6, and total covariance we compute 62. That is 6 plus 15. That we compute total 21 variance covariance. That's why it is called analysis of moment structure. So we compute total 21 because 6 variances and 15 covariances. 62. Covariance occur pairwise. So this is the 21. Okay. So when you compute this 21, now 5 regression weight, 5 regression weight and 6 variances we compute. Already I told you. So what is 5 plus 6? 11. So that means 11 parameters we have to estimate. Out of 11 parameters, we estimate 5 regression weight and 6 variances. So how many are left? 21 minus 11. Because we have total 21. We know only 21 parameters. We know 6 variances and 15 covariances. And with the help of this, we have to estimate which are unknown. Which are unknown? Regression weight are unknown. Which are unknown, we have to, the variances we have to compute. So then, out of 21 minus 11, how many are left? That is 10 are left. These basically 10 is called degrees of freedom. So that part I am showing. Say, sorry. That is okay. So just you think, what is the number of distinct sample movements? 21. I hope it is clear. Hello. Between salary began and job category. Salary began and job category. So there is a covariance between salary began and job category. Job. Clear? This is a covariance. Hello? Because this is called the multicollinearity occurs. Is it clear or not? Hello?
Yes, sir.
And again, we run the process. Again, there are some correlation. Proceed with the example analysis. And again, we try to find the values. So just to check how many parameters to, again, we go to estimate. Then you can understand what is the degrees of freedom. So how many regression weight we are calculating? 5. How many covariance are we are calculating? 1. And how many variance we are calculating? 6. So we are estimating 5 plus 1, 6 plus 6, 12. So obviously, how many estimates are left? 9. That is my degrees of freedom. Is it okay? So
Yes,
that is my degrees of freedom. So if we go to the model fit, say again, this is my model fit. Still, the p-value is less than 0.05 and degrees of freedom is 9. Obviously, model is not fit. So don't, until the p-value is more than 0.05, we don't check this fitness measures. So again, we go for modification index. So still there are some relation. That is the 65 point. There is a relation between salary began and education. So again, we go to the diagram. And there is the covariance between salary began and education. Clear? Salary began and education. So then again, we run the process. Proceed with the analysis. So just to check what is the degrees of freedom 8. Question is why? Because estimates. So we estimate 5 regression weight, 2 covariances, and 6 regression weight. So that's why you have to estimate 13 parameters. So how many are left? 8, 21 minus 13. So the degrees of freedom is 3, 8. So when the degrees of freedom is losing, so we are approaching to the saturated model. That is not good. That's why multicollinearity we cannot consider in case of regression model. Because if there is a multicollinearity, we're losing the degrees of freedom. Okay. So now we go to again the modification indices. So still there are some relationship between job cat and education, because this is 42.814 is a high relationship between job cat and education. So we go to the again diagram. So there is a job cat and education. So this is the job cat and education, job cat and education. So this is the job cat and education. Okay. And again, we run the process. Again, proceed with the analysis. Then we go for the values. So again, that is the degrees of freedom is 7. And why? Because again we go to estimates, then you can understand. These are fixed. Again, we calculate 3 and 4. So 14 parameters to be estimated. 5 regressions, 3 covariances, and 6 variances. So how many are left? 7 are left. So, but the model is not fit because still your p-value is less than 0.05. So again, we check the modification indices. So again, there are some high value, that is the 63 point relationship between previous experience and education. Okay. So go to the previous experience and education. So previous experience and education. So that is the previous experience and education. Education. And again, we check this thing, proceed with the analysis, and there's the value. Now it is clear. If you check here, the p-value is less than, greater than, hello.
Yes, sir.
Yes,
Greater
sir.
than 0.05.
Now we get
Yes,
a
sir.
model. This is my model now. And now you check your all tests. The GFI is very good, AGPI is very good. So naturally, when you write your paper, you write the benchmarking. Only take the benchmarking value because your NFI is very good, RFI is very good, IFI is very good. So naturally, and if you want to, why AMOS is so powerful? I'm showing one thing. Suppose you can ask me, yes, sir, I don't know anything about GFI and I don't know what is the full form of GFI. Then how I write in my research paper? Okay, just no need to do things, just you click GFI and everything will be coming. Is it clear? Hello.
Yes, sir. Yes,
Okay,
sir. Yes, sir.
everything will be coming. So easily you can write the formula of GFI, everything of the references, everything will be coming. That is the importance of AMOS.
So we can copy and we just have to elaborate such thing.
Yeah, I will copy yours, not all part, some relevant part. Okay. And that you can give and you the references.
So actually, in the paper, sir, what are the things that should be minimum requirement for the paper?
Minimum requirement, I'm telling you, minimum requirement, I'm telling you, some R and Python, they are taking, this is RM, GFI, AGFI, NFI, RFI, they are taking this, they are taking some FN, F mean values. Here F mean value is very good. F mean values. They are taking RMSE. That is also very good. And finally, you have to consider the last fit index. That is very, very important. Because initially, when we started this regression model, so that then the sample size was 474. But when you get the prove your model, validate your model, that is showing more than that. That is very good. And if the last fit index shows less than your actual sample size, that means your model is not good, your regression is not working. Okay. So that part you will show. You can show some AIC part, actually, which will be coming good, that part you will show. Okay.
So it means that all the table that are not necessary.
All the things are not necessary, and all the things will not come good. I'm telling you. All good, because question is why you are taking the samples, some population, maybe in case of sample there is a lack of normality, lack of some outlier, there are so many things will happen in the real life data. So how
So,
you explain that
okay,
all
so
will
the
be satisfied?
important part, can you highlight it for us?
Yeah, important factor of say GFI is very important. Okay, very important. Goodness fit measure. Your RMR is very important. Your norm fit index is very important. This is the baseline comparisons. Your RFI is very important. There RFI, and this will come very good. IFI very important. TLI very important. CFI is very important. In some cases, the PA
things in the paper that
If I do not show, that is possible if your sample size is very, very high. Say if you take the 2000 or 3000 sample, but your sample size is only 200 or 300, but you are not showing p-value. So definitely there will be some interrogative sign.
a source paper can be accepted.
If it is asymptotically normal, then you can do that. But you have to prove that. Very nice question. Okay.
No, actually, but for the Scopus level, so all the things should be mentioned clearly before they
Yeah.
accept.
And for the money, if you want to publish in a good journal, you mention everything. Why?
And if some
I'm telling you, a very
Okay.
nice question you told me. Here, the Seaman degrees of freedom value is 0.95. You know,
Yes,
that is
sir.
this is your chi-square. So it is not the central chi-square. It is the non-central chi-square. Because in case of non-central chi-square, Seaman by degrees of freedom is less than 1. That also you have to specify.
Okay.
Okay, that is very nice.
Okay.
And when your Seaman by degrees of freedom is coming more than 1, still the p-value is satisfied. Obviously, it is the central chi-square. And if we check my PPT, I have given that some measures just to show that is a some measures based on, just to check my PPT, there is some measures based on, based on, yeah. So this is the feet measure based on non-central chi-square. Is it clear?
Yes, sir.
And these measures basically based on central chi-square. So the central chi-square means when C mean by degrees of freedom is greater than 1. And these are the measures. So then you have to show that this is my absolute. And what are the absolute measures? These are absolute measures. What are the relative measures? These are the relative fit measures. So you underline, these are my relative measure and these are the value. So this is satisfied. Is it clear? And you give the definition of NFI because Amos will support it. Is it clear? And that's
Yes,
why
sir.
Amos is so powerful.
But very few people can be done from the Amos.
That is, this is not the platform. Okay, don't mind. This is not the right platform. I have shown the concept. I hope you understand. So in this way, you can solve anything. If you want to solve any kind of mediation, moderation problem, you can solve this using SEM. If you want to solve some second order factor analysis, you can solve this. If you want to solve any, some logistic regression, you can use SEM. You can solve discriminant analysis for the validation, use SEM. Because the problem is for the some classification problem, there are so many false positive and false negative will occur. The real problem. So how to manage it and how we show that you are okay perfectly, your model is good enough. Okay. Is it clear or not? Tell me.
I think it is clear, sir, to everyone. And already we
sir.
have questions from the participants.
Okay. Thank you. Actually, I know I'm telling you another part, just 5 minutes I will take.
Sure, sir.
Just 5 minutes.
Sure, sir.
Just a minute. Eh? Okay, this is actually the example of factor analysis, just 5 minutes. So this is one factor. There are 4 variables. Try to understand, huh? Hello.
Yes,
Hello?
sir. Please continue.
Yes,
Please
sir.
continue.
Okay, sir. Okay.
This is the factor 1 is the 4 variables. This is the factor to 2 variables. And initially, I'm solving a very interesting part. say, go to question is why this is a complicated problem. Say, we just SPSS file, then open data, and that is your, this is the problem really. So this is the file, okay? And go to analyze. I'm not going in detail because already you know factor analysis. So dimension reduction factor. So we take the cell, old, FPI, CRR, oil, dollar, foreign. And today I have no time. That's why I discarded two variables. And we go for descriptive. Just we go for correlation, sorry. That is, then you can understand why it is important. Go for extraction. Go for extraction. Go for p-plot. There is a PCA we are applying. And go for rotation. Go for Varimax. And this is scores. Go for save and displace definitely factor score continue. Go for option that is sorted by site and suppress the values. And we replace this 0.05, 0.50 and continue. Very interesting result we get it. So get this factor analysis. So this is your factor analysis. I'm coming to this rotation matrix. And if you check this rotation matrix, so just you think these the four variables will forming a one factor. Is it clear? And two
Yes.
variables will be another factor. But dollar is affecting both the factors. So naturally, when you solve SEM, because if we omit this factor or we could not take the dollar in one factor, because dollar affecting both the factor, one factor positively and one factor negatively. So how we handle this situation? This is the question. How we handle this situation? So you go to, this is my question. So there are four variables, B1, B2, B3, B5, B6. This is my factor 1. And B3, B4, this is my factor 2. But B7, that is the dollar affecting both the factors. Is it clear?
Yes,
Hello?
sir. Yes, sir.
So when you draw this is, and just these are factors, these are called unobserved variable or latent variable. And for each variable, there are some errors. So these are also unobserved variable. And naturally, the same process we apply, we take the file name, we take same process, take the file. This is the file name is correlation matrix. Okay. And this is the correlation matrix. Okay. And simply you again we select the okay, and then just a minute. This is my Amos output. Just to check, this is my model fit. Is it clear?
Yes, sir. Greater than 0.05.
Yeah. And naturally, I have used estimates. So many estimates. I have used so many estimates. This is my regression weights. This is my covariance. And this is my variances. So definitely we have to estimate this. And there is one thing is left only for the identification. I have taken for some factors 1 and 1. That is for identification. That part, no time to discuss. Okay. That is basically for identification. And in this way, we go for model fit. Not only that, these are the measures. Okay, C mean by, and this is the central chi-square. Because C mean by degrees of freedom is more than 1. So we apply only the central chi-square measures, absolute measures, relative measures, parsimony measures. And naturally, when you write in case of NFI, simply you give the detailing of this. Anything, it is given. Anything is given. Okay. Thank you to all. Here I am stop. Okay, stop. Like to stop here. And if you
Thank
have
you
any
very much. Thank you very much. We have to appreciate your level of energy, sir. You have started
Thank
from
you.
6.
Thank you, sir, very much.
So actually, we have
Very
taken.
nice.
Yes, we have already taken the questions in between the session. So I am not recommending any separate question answer session because already you have taken several questions. Further, if you have any question from any participants, you can ask. Otherwise, we will go for our valedictory session because we are already too late, right?
Okay.
So
Sorry,
if
sorry.
any question from your end, otherwise we'll go for the valedictory session because our guest is waiting for a long time. So
Okay. Thank you, all participants.
any question from any participants?
No,
Okay.
sir, we have done according to questions.
Thank you
Yeah.
very much. So now we are going forward to our valedictory session, the last part of our 5-day faculty development program. So today we have our chief guest, Professor D.K. Madan, Secretary, Indian Economic Association. Sir, please unmute yourself and address our participants. We are really honored that you are present today and you accepted our invitation. Thank you very much. Please address our participants in this valedictory session.
Yes, thank you, Dr. Sandipta Kumar Ghosh. I am very much happy to address this gathering. Firstly, esteemed Dr. Siba Prasad Mohapatra, Principal, Bharatiya Vidya Bhavan Institute of Management Studies. Dr. Sandipta Kumar Ghosh, convener of this online FDP. Faculty members of the Institute of Management Studies, and my dear participants. Good evening to all of you. I am very much thankful to all of you for attending this program that was run by in collaboration with Indian Economic Association. Our association is very much old, and I am happy to share this thing that this association that was founded in Kolkata in the year 1917 by Professor Charles Hamilton. And it was in December 1917 when this Indian Economic Association was founded. And the main objectives of this association, that is mainly for debate and discussion among the scholars or economists of the country for policy-oriented issues. So IEA is a very oldest association in social sciences, and it is the second oldest after this Indian Science Congress Association. So IA organizes annual conference, seminar, and so many extension lectures in the country. IA promotes the interest of the members, mainly the public, that is very much guided through our association. So IA has organized 105 annual conferences to date, and 106th annual conference of Indian Economic Association is to be held in the University of Delhi during 21st to 23rd December 2023. So I invite all the participants to participate in this annual conference of IA in Delhi, and further I am very much thankful to the organizers for organizing this online FDP, that is a 5-day FDP from 28th November to till today. And the topic is very much relevant one. That is multi-variant data analysis and structural equation modeling using SPSS. So SPSS actually we are using since long. I just share with you, I did my PhD in 1993. And then this statistical package was social sciences, this SPSS, that was not available at that time. But now it is a very good thing that through SPSS, we can use any modeling, we can use analysis for our data and information. And that's why the research scholars can benefit through the use of this SPSS. This FDP, that is also in collaboration with the SPSS in addition to IA. So in that way also, I think all the participants would have been benefited on this account, because research methodology is a very important thing, especially for the PhD students. And when we teach our PhD students, actually in that sense, this type of courses that are very much beneficial to them. So by organizing this online FDP, especially in the evening time, and that's I think all the participants that would have been benefited a lot. So in the end, I am very much thankful to the Bharatiya Vidya Bhavan Institute of Management Study for organizing such event in collaboration with Indian Economic Association. So thank you very much. Thank you.
Thank you very much, sir. I know you are waiting for last half an hour, but I will again request you to stay for another 5 or 6 minutes, because the session will be concluded by 5 or 6 minutes. So please stay with us, sir. This is our request. Okay. So
yes.
And thank you for giving us your precious time. So I would request few of the participants, they can share their experience regarding this faculty development program, so they can turn on their audio and video one by one, but in 1 or 2 lines, not too much time. Please.
Good evening.
Anyone?
Good evening, respected teachers, and good evening, respected Professor Sudipto Ghosh, sir, and my fellow participants. My name is Dr. Shohini Banerjee. I'm from IIS WBM Kolkata, where I'm working as an associate professor. First of all, my heartiest thanks to Professor Sudipto Kumar Ghosh for organizing this very relevant FDP on this very relevant topic. It has helped us a lot, and it's not just good for PhD students, it's good for PhD supervisors also. And hats off to BIMS for arranging this this wonderful FDP on this very relevant topic. And this particular FDP had wonderful resource persons who went at length. The study materials which we received will be helpful to us forever. And it is also helpful for those of us who are trying to work as PhD guides. So it's attending this course is a win-win situation. And thank you so much for the dynamic timing of this particular FDP. It's just 2 hours. In 5 days, we have covered a lot. And it was an awesome and hermeneutic and heuristic experience. I have attended several FDPs, but this was extremely well organized, and it was planned with meticulous details. So thank you so much. Thank you so much. We have tremendously benefited from it. Thank you, sir, and kindly think of organizing many more such programs, and I will register for them. Thank you so much. And my pranam to the gurus who taught us, and my salute to my fellow participants, and also my pranam to Professor Sudipto Ghosh. You are a very young person, but in knowledge and in terms of your planning, you are very sagacious. Thank you so much, sir. Thank you.
Thank you, ma'am. This is a completely team effort from the Bharatiya Vidya Institute of Management Science, Kolkata. Everyone from the Bharatiya Vidya Institute of Management Science gave their full effort to make successful of this faculty development program. So this is not only my planning. This is an absolute teamwork. And from the beginning, Dr. Gautam Bandhopadhyay with us for planning the whole faculty development program. Day-wise schedule has been made by the guidance of Professor Gautam Bandhopadhyay. So thank you, sir. Any external participants? Yes, thank you, ma'am. Thank you very much. Any external participants can share their experience? Can you please turn on their video and audio? You can share your experience. Otherwise, we can go for a final address by our principal, sir. After that, there will be a vote of thanks. So I will go to our honorable principal, sir, Dr. Shiva Prasad Mahapatra, for his address. Please, sir.
Yeah. Thank you, Dr. Sudipto. Thanks to all the participants, in particular, those who have spared every day evening after their office hours to understand multivariate data analysis and structural equation modeling. My thanks are due to Indian Economic Association in particular, and thanks to the President and Secretary, Professor Dr. Madan, who rightly said that today research has developed in much way through the SPSS and other softwares. Today you could know about AMOS. I can tell you that the common term in this whole FDP is research. I am sure whoever is participant, maybe as a resource person, maybe as an organizer, or maybe as a participant, this keyword research is inevitable for all of us. And I am sure those who are learners also, they must have some takeaway. And rightly, as one of the participants was giving the feedback, it is also very much important for the supervisors who are there to guide the students. So ultimately, I could feel that we have benefited in much better way because of the wonderful deliberation by the resource persons. Heartfelt thanks to Professor Gautam Bandhopadhyay, sir. I have personally met you, and today I have seen you from 6:30 till now. You are so energetic, as rightly said by Dr. Sudipto. Sir, your blessings and support made our FDP much smoother. And whatever thanks I will give you, that will not suffice. But surely your guidance has helped us. And Indian Economic Association, I'll tell you, as sir was just telling, it is one of the wonderful associations at present who is catering to the need of research through various international conferences I am seeing. I'll request Madan sir, if he can extend us support, we will surely organize an international conference at Bharatiya Bhavan Institute of Management Science. Particularly physically, I'll be very happy. Otherwise, we may go still virtually. But sir, we will request you to extend your association support in our coming research-related endeavors. And all my colleagues, as Dr. Sudipta was telling, they are doing a lot of hard work behind the scene. They are not available on screen, but their support is very much important for all of us. They are eagerly supporting, even as I said, this topic is similar or known to people, but the more you dwelt upon it, you will learn it better and better. Sometimes we felt that subject is common, but when professors delivered, we could know that how much we don't know. So that is the beauty of research. The more you culture into it, you will learn. And very nicely participants were putting the questions in between. So I was feeling very happy that the purpose of this FDP could met in a very nice manner. And SPSS, the team, I really thank them, because the fast support we got from SPSS while we designed this, though more of SPSS will be known when we'll practice ourselves, but thanks to them also. And thanks to the management of Bharatiya Vidya Bhavan, in particular, Dr. G.V. Subramaniam, the very first day when Dr. Sudipta sent me the proposal of this FDP, within a minute, he said, absolutely beauty, so you can go ahead. So without knowing how to organize, he said, this concept is very nice. So thanks to our director, Dr. G.V. Subramaniam, and all the persons, technical persons behind this Zoom and all that, thanks to all. Now it's on to you, Dr. Sudipta.
Thank you, sir. Thank you very much. So from our end, one of our senior professor, Professor Shemonti Debroy, she will deliver the vote of thanks. So I will request, madam, please unmute yourself and turn on your videos, ma'am, and please go ahead. Madam, you are not visible and audible. Yes, yes.
Am I audible?
Yes, absolutely, ma'am. Please go ahead.
Good evening to all present in the meeting here. I thank Dr. Ghosh for giving me the privilege to offer the vote of thanks in this valedictory session. This is indeed a great honor for me to wind up the most engrossing and learning-centric week this time. We are all aware that research is occupying important space in the academic sphere. It facilitates knowledge, building, and intrinsic learning. And knowledge and application of statistical tools and procedures is an integral part of any research activity. In this scenario, it is pertinent for everyone associated with academics and research to be conversant and updated with the latest statistical procedures. In this respect, this FDP, titled Multivariate Data Analysis with and Structural Equation Modeling using SPSS, is highly significant and appropriate. The participants really got a meaningful insight and understanding into some very useful tools and practices of statistics. The FDP opened with a vivid discussion on factor analysis by Dr. Suresh Kumar Sharma from Punjab University of Chandigarh. It was followed by a detailed deliberation on multiple regression analysis by Dr. Bandhopadhyay, former professor and dean of IIM Ahmedabad. This was followed by a discourse on ANOVA and MANOVA by Dr. Anirban Sarkar, professor of the Department of Commerce and Management from West Bengal State University. The penultimate day brought out the application and inference of discriminant analysis and logistic regression by Dr. Ravindra Kumar Jana, professor of IMT Nagpur. The FDP culminated with the final day deliberation of structured equation modeling by renowned and our very well-known Professor Dr. Gautam Bandhopadhyay of NIT Durgapur. I've attended several lectures of GB sir, and every time I've learned something new and something more. I would like to extend wholehearted thanks and regard to all the respected and revered resource persons for making time from their busy schedule and consenting to impart such important lessons for the participants. The FDP has been highly successful with registrations from 13 different states of India, one NRI delegate and one delegate from Nepal, foreign delegate that is. I would like to thank all the delegates for showing interest in the program and your active participation. I'm sure all of you had a meaningful and objective learning from this program, which you would further apply in your scope of activities. And above all, I would like to extend overwhelming regards and gratitude to Dr. Sudipta Ghosh for conceptualizing this FDP and executing it so smoothly. He deserves all accolades and applause for bringing in so many resource persons and delegates from different parts of India under one umbrella and making this FDP a grand success. Finally, I would like to thank our principal sir, Dr. S.P. Mahapatra, for his encouragement and support in organizing the FDP, and also all my faculty colleagues for their interest and participation. Let us now all call an end to this with a desire that we will meet again in some more such programs in a very near future. May God bless us all. Good night.
Thank you very much. Thank you very much. Yes, there is no further words needed after this wonderful deliberation by Semonti ma'am. So thank you very much, Professor Gautam Bandhopadhyay. Thank you, Professor D.K. Madan sir. Thank you, our principal sir. And thanks all the participants over here. And we are ending our faculty development program today, and we will deliver all the materials collected from the resource persons to your email ID, and we will try to provide the recordings of all the sessions to you. Okay, and by next 1 month we will deliver the certificates through email. Okay, by next 1 month. So no need to worry about it. All the materials will be delivered to your email ID on time. Thank you very much. And we are ending the session and the program here. Bye.
Excuse me, sir. One
Yes,
thing
please.
is that, so
Please.
for the coming international conference, please send us email about it.
Sure,
So
sure. We will share
try to
whatever events will be there in our campus. You will get a notification from our end. There is no need to worry. Okay.
Okay. Thank you, sir.
Thank you. Thank you very much. We are ending the session here. Bye. Good night.
Thank you, Sudipta. I'm leaving.
Thank you, sir. Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Yes, thank you.
Thank you, sir. We'll be in touch, sir. We'll be in touch. Thank you,
Yes,
sir.
yes, we will be in touch, and we will collaborate further also. Thank you.
Sure. As our principal sir told.
Yes.
Yeah.
We can even you can organize next annual conference in your institution.
Absolutely, sir. Absolutely. We'll be really happy, sir.
Yes.
Really happy. It will be great. Thank you, sir.
Yes.
Thank you very much, sir.
Okay.
Thank you, Dr. Sudipta.
Thank you. Thank you, sir.
Professor Madan.